All right, welcome back, guys. In this module, we're going to talk all about JavaScript, the language that powers the web. Now, I reckon that I can guess your age based on whether if you recognize this logo. So the people who recognize it, or may have even used it, I reckon that you're probably over the age of 30, or you're just really savvy with your internet history. Now, for those of you guys who don't recognize this symbol, this is the logo for Netscape Navigator, the browser that dominated the 90s. Now, what about these logos? I'm willing to guess that almost everybody will know at least one of these logos, if not all of them. And what do they all have in common? Well, there was one company that invested in all of these startups, and that's Andreessen Horowitz. And the Andreessen in this case refers to Mark Andreessen, who was one of the principal makers of the Netscape Navigator. So in the beginning, way before Chrome or Firefox, Safari, or even Internet Explorer, there was a browser called Mosaic. And Mosaic was something that Mark worked on even while he was at university. And when he finished university, he began to work on Netscape. And at one point, Netscape Navigator held over 80% of the market share in terms of browser usage. Subsequently, there was a huge browser war. And there was a big kerfuffle between Netscape, which was the dominant force, and Internet Explorer. And the result was the death of Netscape and the Netscape Communications Company. But a lot of that technology was transported and incorporated into the modern day Firefox. So when we talk about Mosaic and Netscape, this really was the beginning of web browsing as we know it today. So I want to take you back. We're going to time travel to 1995. And this was the time before Tupac was killed and NSYNC was plastered all over my room, and a time when people would fight each other for the latest version of Windows 95. At this point in time, HTML websites were all form and no function. And when a website did in fact need some functionality, such as retrieving a piece of data that you searched for, or just calculating something, or converting between different units, the website had to send that request to the data server, and it was in the data server where all of this computation and business logic happened, and then it would return the web page that contained the new data. Now, the team at Netscape wanted something a little bit different. They envisioned a future where the web was more dynamic, with animations and real-time user interaction. And in order to enable this, you needed to take away the server and have the code be able to run on the browser. So in order to do this, they wanted to create a small scripting language. The requirements were that this language had to be simple and it had to be really easy so that even non-developers and non-programmers could use it to add functionality to websites. So they contracted this guy, Brendan Eich, to create that programming language. And as internet history and internet lore goes, Brendan proceeded to sit down with the team, and while there were other people who tried to lose a guy in 10 days, Brendan was able to create JavaScript in 10 days. And now we can't even imagine what the world would look like without JavaScript. So let's try and turn off JavaScript in our Chrome browser and see what we end up with. So if you want to play along with me, you can go into your settings and search for JavaScript, and then it will highlight content settings. And if you click on that, you can navigate to JavaScript allowed, and we're going to switch it off. Now let's go on to Twitter and let's see what that looks like. So we're getting the mobile version of Twitter that doesn't require JavaScript, but you'll see that the design looks completely different from the Twitter that you get on your phone. And also, if you go onto the compose section and you try to write a tweet, you're missing that really key bit of JavaScript that tells you how many characters you've written and how many you have left. So if you tweeted all of this, you'll get some part of your tweet cut off and you won't even be able to know which part. So this is Twitter without JavaScript. Now, if I load up the New York Times while I have JavaScript enabled, you can see that we've got all of these ads showing up. So an interesting side effect of disabling JavaScript is you actually end up having an ad-free website where you can see it's trying to load up the ads, but because it requires JavaScript to do so, we end up with an ad-free browsing experience. So there are even people who choose to switch off JavaScript for reasons such as this. But you'll end up running into a huge amount of problems as well. For example, sites like YouTube just simply won't even load up with JavaScript disabled. And it's the same problem on Netflix. So the world is actually quite a scary place without JavaScript. And it goes to show just how reliant we've become on this single programming language. The web certainly is dominated by it. Now, JavaScript wasn't even always called JavaScript. In fact, when Brendan first created it, it was actually called LiveScript. And then the people at Microsoft decided to try and reverse engineer the program, and they ended up with something called JScript. And so there were all these slightly different versions of JavaScript that was being run on the web, and it was starting to get quite confusing. So the Europeans did what Europeans do best, and they decided to standardize the language. And that's where you get the ECMA script from. And that stands for the European Computer Manufacturers Association script. And the only reason why this is interesting is that often you'll see different versions of JavaScript not referred to as js5 or js6, but as ES6 or ES7. And the ES comes, of course, from ECMAScript. All right, so enough history. Why is it called JavaScript anyways? What does the script stand for? Well, just as you have scripts in plays where it tells the actors what they should do, the scripting languages does much the same thing with regards to websites. So, for example, let's say that we have a script and we have some actors, Gwyneth Paltrow and Brad Pitt. So obviously we're making a very high-end movie here. So in the script, you might tell your actors that after Gwyneth appears on stage for 1 second, Brad should appear. And then Gwyneth should say hello. And then there's a delay of 1 second when Brad needs to say hello. So this is the script. So this is how it would play out. So by writing these instructions and telling the actors what they should say, we're able to determine how our play should work. Now, in our world of web development, the script is JavaScript, and the actors are, for example, the HTML elements. And Gwyneth would be, say, for example, an H1 element, and Brad could be a paragraph element. So clearly the web developer's version of a play is much less sexy, but nonetheless, it still can do exactly the same things. So in this case, our script looks more like this. First, unhide H1, then after 1 second delay, unhide the paragraph tag. Then the H1 should change its text to the word hello, and the paragraph tag should change its text to the word world. So let's give that a go. There we go. So in this case, we're using our JavaScript to tell our players or our elements what it should do. And this is how scripting languages work. So the other question that I tend to get from students is JavaScript similar to Java? And what exactly is their relationship? And to those students, I often refer to something that a computer science professor once told me, which is Java and JavaScript have about as much in common as car and carpet. And the only reason why JavaScript was called JavaScript was because in the 90s, the word Java was about as hot as the word blockchain in today's world. And you may or may not have read the story about the Long Island Iced Tea Company, which had its stock double in price almost overnight by simply changing its name to Long Blockchain Company. So that was exactly what happened in the 90s. Everybody wanted the word Java in their name, but JavaScript and Java actually have some big differences. And the main difference is that JavaScript is an interpreted programming language, whereas Java is a compiled programming language. So I'll defer to this brilliant cartoon from a TV show called Bits and Bytes from the 1980s to explain this. It's from a really awesome Canadian series, and I'll include a link to the video in the resources section of this lesson. Now, whereas in the olden days, interpreted languages tend to be seen as almost like toy languages. They weren't so powerful, they were very slow, and they had to execute all the instructions line by line. Whereas compiled languages were seen as the more serious languages, and you end up with very fast running programs. Now, today, modern JavaScript is used in all sorts of places. Whereas traditionally it was a front-end language that was meant to add some animations to your website or allow a little bit of user interaction. But nowadays, JavaScript can be seen in frameworks ranging from the front end to the back end and everything in between. And later in this course, we're going to learn about a lot of those frameworks. Now, the other great thing about JavaScript is that it's the one language that is supported by all of the major browsers. While you can use other languages that can be compiled into JavaScript and run on the browser, it is still the language that powers the web. And this is evident from the popularity of JavaScript. So this is a graph that's compiled by RedMonk, and this is for January 2018. And you can see that at the top right corner, the most popular language of 2018 is still JavaScript, closely followed by Java. So whenever students ask me, what is the language that I should learn first? Or what is the best programming language to become skilled in? I tend to tell them that, well, that depends on what you want to build. If you want to build an iOS app, then that means you should learn Swift. If you want to build an Android app, then you need to know about Java. But if you want to build websites and web apps, then JavaScript is going to be your close ally. Although if you're not careful, it can also be your enemy. So in the coming lessons, we're going to learn about best practice in terms of using JavaScript and all of the good parts that this language offers. So for all of that and more, I'll see you on the next lesson. Alright, so now that we've heard all about how awesome JavaScript can be, then it's really time to give it a spin and see how we can start adding behavior to our website by learning and using just a little bit of JavaScript. So I want you to open up a brand new tab inside Chrome, and we're going to go into the menu under View, and then we're going to go into Developer, and you can navigate to the JavaScript console. Now, this is pretty cool because it allows you to start writing JavaScript straight away, and it will run them as you hit enter. So for example, we can write something like alert, and then we're going to open up some round brackets or parentheses, and we're going to tell it what we want it to alert us. So let's just get it to write hello. And then at the end, we're going to close everything off with this semicolon. So now if I hit enter, Chrome will run this line of code, and as you can see, it brings up a pop-up, and that pop-up has the message of hello. Now, if you hit OK, the pop-up will disappear, and that is the end of our alert. Now, while the console is useful, it has one downside. So, for example, if I wanted two alerts to happen, for example, I want one pop-up to say hello, and then I want another pop-up straight afterwards to say world. As soon as I hit enter, my first line is already executed, and I don't get to go to the next line and finish off what I was writing, which was a multi-line instruction. So the way that you can get around this is by holding down Shift and hitting enter, and that takes you on to the next line, and so you can now write world, exclamation mark, close off the round brackets, and then finally add a semicolon. So now if I hit enter, it will execute the first pop-up which says hello, and when I dismiss that one, it will straight away execute the next line of code, which is a pop-up that should say world. Now, this is a little bit cumbersome, and very often when you're typing inside the console and you're writing multi-line code, you forget to hold down Shift and you hit enter and you've lost all of your progress. And it's a little bit painful, so I want to show you another way of writing JavaScript code that can be executed inside Chrome. So if you go ahead and go to the next tab, which is Sources, and if you click on it, you get taken to this tab. Now, on the left corner here, you see this little arrow, and I want you to click on it and go to Snippets. Now, this is a little bit of a hidden area in Chrome, as not a lot of people even know about it, but it's really, really useful for what we're trying to do. Now, once you're here, you're going to create a new snippet by clicking on this plus new snippet button, and you're going to call your script index.js or whatever it is that you want to call it. So now you can see that we've got these JavaScript files, and it's showing up over here almost like what we've got going on inside Atom. So I'm going to close off the hello.js and I'm going to remove it so that we only have one file and it's less confusing. Now inside this file here, I can start writing code. So for example, I can say alert hello and then alert world. And I can write as many lines of code as I wish. And once I'm done, I can go over to the bottom right corner here and I can press it to run my code. So this is slightly different from how console works. Console's kind of intended for you to test out lines of code. So you write one line, you hit enter, you test it out. But the snippet editor is meant to execute your code only once you've finished writing the entire script. So now if I hit this button, it will run my code and I will get one alert and then another alert. And you can see that it's actually converting it into these instructions line by line inside the console. So the snippets editor is what we'll be using in the next few lessons as we learn more about JavaScript, and we'll use it to complete some of the exercises and challenges. Now, how do we know which instructions the browser will listen to and which instructions are just gobbledygook? You know, so if I said say hello, then it's not really going to work because it's not a real command. So once it goes through hello and world, then my code actually crashes. And in the console, I get this error message that says, uncaught reference error, say is not defined. So to translate that to English, the browser's basically trying to tell you that I have no idea what this say keyword is that you're trying to tell me. And it's not a real instruction. I don't know what you want me to do. You have to look at the proper keywords and use something that I can accept and I can execute. So how do we know what those keywords are? Well, if we head over to our trusty MDN web docs and we select JavaScript as our technology, then you can see that we've got all the information that we need in the world in order to get started using JavaScript. Now, you can either scroll through the left menu and look through all the different sections that they've compiled for you, or we can just go straight in and start searching for this alert that we've used. So you can see that the first result I get back is something called window.alert. And if you click on it, it tells you that this is a method that displays an alert dialog, which is a pop-up, with the optional specified content and an OK button. So the syntax looks somewhat like this. And they give you an example of what code you would need to write and what it would produce. So you can see that the full version of triggering a pop-up is by saying window.alert, and sometimes you'll see programmers writing that out. But in most cases, most people will go with the shorter version, which is simply just using the keyword alert and then enclosing your message inside the round brackets or parentheses. So let's take a look at this line of code in more detail. Now, the alert in this case is a keyword. And as we mentioned before, the keywords are special. You can't just use any word you wish. It has to be something that the browser knows about. And in this case, the browser knows that when you write alert, you're trying to tell it to create a pop-up. And this is also known as a function because it's a little bit of functionality. It gets the browser to do something, not like what we've done so far, which is just to change the appearance of the website. This is actually a little bit of behavior, which we got by writing JavaScript code. The middle part here in green is the message. This is what we want to show up in the pop-up. And you can change that message to anything you wish. And it doesn't matter what you write, it could be gobbledygook for all the browser cares, but it will faithfully display that message in the pop-up. And finally, at the end, there is this semicolon. And that denotes the end of this sentence or the end of your instruction, so that the browser doesn't get confused between one line and the next line and doesn't combine it into a single line of instruction. So it might seem a little bit confusing why we have these semicolons and parentheses and these quotation marks, but all it is just a part of the grammar of the programming language. So just as in English, we could type out something like say, colon, quotation marks, hello, full stop. And this, as a human, we will know that it's trying to tell us to say the word hello. In programming, it's exactly the same. We need some of these symbols to tell the browser or the computer what it should do. So, for example, the semicolon is just like the full stop in English. This is the end of the sentence or the end of the instruction. And the quotation marks works exactly the same. It denotes that whatever is between the quotation marks is not a part of the functionality or the code. It's simply just a quote, or as we would say in programming, a string of characters. Now, the round brackets or the parentheses dictate what should be the message. So everything that's in between the open and closing brackets are the things that will be included in the alert pop-up. And finally, the alert is just a keyword that the browser recognizes and knows what it should do when it sees that in the command. So as you can see, in different languages, we might have different syntax or different symbols that we use. And that's exactly the same thing in programming as well. So looking at Ruby code or Python or Java, you'll see that sometimes you have different syntax or different symbols are used. But at the end of the day, it's just a way of trying to create grammar so that the computer can better understand what it is that we're trying to tell it to do. Now, there's a couple important things I want you to notice. And the first is that when you type quotation marks in a word processor, for example, Word or Google Docs, then you actually get very different symbols from what you use in programming. And the reason is because in programming, the open quotation and the closing quotation are the same symbol, whereas in a word processor, we care more about how it looks. So the open quote and the closing quote are actually completely different symbols. And if you try to run this line of code using these symbols, then it won't work. But thankfully, whenever you're typing inside a text editor that's intended for code, so for example, the snippets tool or in Atom, then it will automatically give you the programming quotes instead of the stylistic quotes. It only is a problem when you copy and paste things from things like Word or from notes, and you have to be careful about what symbols you're copying in, which is one of the reasons that typing code out and getting more practice is always better than just copying and pasting. The other thing I want to show you is that when I write code in the coming lessons and modules, I will write it so that there is no space between the keyword, the round braces, the quotation marks, and also the semicolons. There's no spaces in between here. Now, you can also add spaces, as many as you wish, but in this course, I want to show you the best practice in terms of stylistic choices. So I want to teach you the way that most programmers will structure their code. And while it doesn't change the behavior of your code, it will make your code much more uniform with every other programmer's code, and it'll make it more readable and make it easier for other people to understand your code. Now, the other stylistic choice is that when you have the hello inside quotation marks, you can either choose to use single quotes or double quotes. The browser and the computer doesn't care. It treats it as the same. But as a style convention, most JavaScript programmers in this case will use the double quotes over the single quotes. And later on, I'll show you cases where the single quotes are preferred. But when we're talking about a quote, a string, a piece of text, basically something that we're writing and we're telling the computer that this is not code, this is just text, so that it doesn't treat it as a keyword like alert, then we're going to be using the double quotes. Now, if all of this seems very confusing in terms of which style choices to make, then I want you to know that in this course, I will be teaching you best practice in terms of structuring your code and your syntax. But if you're writing code by yourself and you ever get confused about which stylistic choices to make, then I want you to take a look at this website and bookmark it, because it's going to be really, really useful in the coming months and years as you develop into a fully fledged JavaScript developer. And this is a living document that's been compiled by lots and lots of people, some people who are really influential in the community as well. And essentially, the key message is that all code in any code base should look like a single person typed it, no matter how many people contributed. So that means that everybody has to stick to the same style so that the whole project looks consistent. Now, it might be that at the current stage, this document is a little bit too advanced, especially if you're learning programming for the first time. But after you complete this course and as you start going on to build your own projects, then this is a really handy reference guide to just look back at every so often to check to make sure that you are using the right syntax and the right structure. And for me, it's a little bit like the book, The Elements of Style, which is a writing style guide for writing in English. And every so often, after, a year or so, I tend to read this small book just to refresh myself on, whether if I'm using the correct grammatical style, whether if I'm using the Oxford comma. And it's exactly the same for code. So it's not a large document, and it's something that you can browse through as you get more and more experienced in programming. Now, in the next lesson, we're going to continue our JavaScript learning, and I'm going to talk about different data types and the primitive data types that we can use when we're writing JavaScript code. So for all of that and more, I'll see you on the next lesson. All right, welcome back, guys. In the last lesson, we saw how we could use the alert keyword in JavaScript to create a pop-up in our browser. And the pop-up would say whatever is in between the two round brackets. In this case, it would be hello. Now, how does the browser know which part of this code is actual code, i.e. keywords like alert, and which parts of this line is the text that we want to display? Well, there's something that we've added here that tells the browser that this is a string. And the secret is, of course, these two little quotation marks, because everything that they enclose gets interpreted by the computer as a string, so that it gets taken out of the code and gets interpreted as text. And this is really important because all the code that we write is written with text, right? With characters in the English alphabet. And it's really important that the computer knows which part are the code and which parts are the text. And this is a great place to introduce you to something called data types, because a string is exactly that. It's a data type. It's a way of classifying data to tell the computer how the program intends to use the data. In this case, it's simply the text that we want to be displayed in our pop-up. And you will see this data type across all programming languages, and it's pretty much always called a string. And that's because it's simply a string of characters, just as you would have a string of pearls. And in the coming lessons, whenever I refer to string, I'm always talking about text that's not meant to be interpreted as code, or just a string of characters. Now, there are other data types other than strings. For example, there are numbers. And numbers, because they have different symbols from the alphabet that we use for code, then we don't actually need any special symbols to tell the computer that this is a number. We can just simply type the number. And finally, the last data type I want to show you is the Boolean. And this is a data type that describes data that is either true or false. And we're going to be using a combination of all of these data types in order to create the programs and the websites in the coming lessons and modules. So this really is the groundwork, and it's the fundamentals of how all programming languages work. So let's take a look at this in more detail. I want you to open up your console, so you can do that by going to View, Developer, JavaScript Console, and you'll see it show up down here. And in the console, you can do a number of things. So you can, for example, add numbers to each other. So 2 plus 3 equals 5, and you get an output after you hit enter. You can also write the code that we wrote before, which is the alert keyword, and that tells the browser that we want a pop-up that says the output of 2 plus 3. So once I hit enter, we'll get a pop-up that says 5. Now, I want to show you another keyword other than the alert, and this is called type of. And this actually tells you what is the data type of whatever it is that you put within these round brackets. So for example, if I put 23 in here, then I will get the output of this is a number. But if I wrote something like type of my name inside some quotation marks, then I get told that this is a string. And finally, let's just, for completion's sake, use a Boolean, for example, true. Then I get told that this is a Boolean. So in the coming lessons and modules, we'll be using all of these different data types in order to create our websites and web apps. And understanding the fact that different pieces of data can have different data types will be a foundation block towards building those websites and web apps. Now, in the next lesson, we're going to talk about another foundation block for all programming languages, which is the variable. So for all of that and more, I'll see you on the next lesson. Alright guys, so we've been hanging out for a little while now, but let me formally introduce myself. My name is Angela, and I live in London. My greatest ambition in life is to eat my own body weight in sushi. Now, I want you to commit this to your memory. This truly is the first step towards our wonderful blossoming friendship. Because instead of politely asking you, do you know anyone else called Angela who lives in London? I can now ask you, do you know anyone else with my name who lives in my city? Or do you know anyone else who has the same ambitions as me? This means that whenever I want to talk to you about my name, location, or ambitions, I don't have to repeat myself and tell you the information that you've already committed to memory. So this is the same reason why we have something called variables in programming. In the same way that you've committed my name to your memory, we can commit pieces of data to the memory of the computer. But first, we need to enable the user to enter a piece of information. So let's learn about the prompt keyword. Now, if you open up Chrome and go to our developer tools, we're going to head into our sources to work inside Chrome snippets. Now, inside the same index.js, it's just a blank file at the moment. And I want you to write a prompt that asks the user, what is your name? And now, if I hit Command Enter or Control Enter on Windows, or simply just click over here, then it will run my code and it will show me a prompt. Now, a prompt is pretty much identical to an alert or a pop-up, but in this case, it actually allows the user to input something, namely a piece of text. So I'm going to tell it that my name is Angela. So what happened to that piece of data? How can I retrieve it back? What exactly just happened? Well, nothing. It's not committed to memory, so that piece of information is just out there in the air and it's lost. So how can we remember it? Well, we can use something called a variable. So for example, I can write something like var, my name is equal to the string, that's Angela. So now if I hit run, and I go into the console and type my name and hit enter, then it will know that my name is equal to the string Angela because I've saved this piece of data inside a variable. Now, let's take a look at variables in more detail. This is what the syntax looks like. The first word var is a keyword. And just as alert is a keyword or prompt is a keyword, this tells us that we are creating a new variable or creating a new data container. And that container has the name of whatever it is that we give it here. In this case, we called it my name. And then we set that variable to be equal to the value, which is the string Angela. Now, every time we refer to my name, the computer knows that we're talking about the string Angela. So let's dissect this syntax a little bit more and see what's happening behind the scenes. So whenever the computer encounters the keyword var, it essentially knows that it has to construct a new container or a new box. And this box gets given a name, whatever it is that we put after the word var. And in this case, we call it my name. Now, after the equal sign is what we're going to place inside the box. And in this case, it's the string that's Angela. And now we get to the end, there's a semicolon, we've finished our line of code, and that box has a lid placed on it. Now, the special feature of a var, and why it's called a var, is because it stands for the word variable. So that means you can vary the data that you keep inside it. So in the next instance, if I decide that I didn't really like my name and I wanted to change it, then I can tap into that same container by writing its name, in this case my name, and I can set it to equal a new value. And what that means is that the computer will find the box that has the name of my name, it'll take out the content that's currently contained and delete it, and then it will reassign it a new value depending on what I wrote on the right-hand side of the equal sign. And with that line of code, I've varied what's contained inside my box. Notice that in this case, I don't have to repeat the keyword var again. The word var is only used when you're constructing a new box to contain your data, or when you're constructing a new variable. When you decide to use the variable, or when you decide to change the variable, you don't need to use that keyword var anymore. It only needs to occur once in the lifetime of your variables. Now we know that we've saved this piece of data into the variable that's called my name. As a challenge, I want you to create an alert that shows the content of this variable, but you're not allowed to type any strings. Pause the video and see if you can figure it out. Alright, so this shouldn't be too hard. We already know how to write alerts. We just simply write the alert keyword, we open some parentheses, and inside we place whatever it is that we want to be displayed inside the alert. And in this case, we want to show the data that's contained inside the variable my name. So all we have to do is to refer to the name that we gave that variable. In this case, it's my name, and we can now hit run. And you can see that Angela gets printed because that is the value that's contained inside this variable or inside this box. So it's like going to a shelf where you've got lots of storage boxes and pulling out the box that's labeled my name to discover what's contained inside, which is the string Angela. Now, in the same way, we can save the information that the user inputs to our website. So, for example, we know that my name is equal to Angela, but what if we used a prompt to ask the user, what is your name? Now, unlike the last time, we're not going to lose this piece of information. We're going to keep it inside a variable. And that variable, we're going to give it a name. And we can call it anything we want. But let's think of something that makes sense. How about your name? And so now we're creating a new variable that's called your name. And the value of this variable is equal to whatever the user types into the prompt. So now let's hit run. And here's my prompt. What is your name? So let's say that my name is now Jack Bauer, my favorite person in the world. And hit OK. Now, if I go into the console and I type your name and hit enter, the computer knows the value that's associated with that variable is Jack Bauer. So now we can create an alert that combines the values of both of those variables. So we can write alert, my name is space plus my name as the variable plus comma space welcome to my course space plus the second variable, which is your name, plus finally maybe an exclamation mark. And now we close off that line of code with a semicolon, and I don't need these two lines of code anymore because that data has already been committed to the memory of the computer. So I can delete that. And now if I hit run, then you can see that it's created this message. My name is Angela. Welcome to my course, Jack Bauer, exclamation mark. So you can see that it's substituted these two places for the value that's been stored inside my name and your name. And it's able to create this message without me having to explicitly say what these two things are. So in this lesson, I wanted to introduce you to the power of variables and how we can use it to store pieces of data. So we don't have to repeat ourselves and we can refer back to it later in the rest of our code. And on a more practical level, you might have a case where you create a variable that's called game level and you set it equal to 1 to begin with. And then as the user goes through the levels, then you can change the value of game level each time. So say they complete the first level, then you can change this thing game level to 2, and then you can keep changing this as they progress. And whenever you or the user wants to find out which level, then you can simply use an alert and say show the game level. Now you'll see 3. Or if you want to make it more fancy, then you can add a string that says your level is currently space plus game level. So you see that your level is currently 3. Now, I hope you enjoyed this lesson. In the next lesson, we're going to look at some of the rules around how you should name your variables. So for all of that and more, I'll see you on the next lesson. Alright guys, in the next lesson, I've got a coding exercise for you, and it's meant to test your understanding of JavaScript variables. Now, when you head over to the next lesson, you'll find a section with the instructions at the top and your code file at the bottom. Now, the goal is to switch the values that are held in two variables around. So to begin, we have a variable A, which holds the value 3, and the variable B, which holds the value 8. Now, you have to write some code on lines 7, 8, and 9 so that the values are switched around, so that A holds 8 instead, and B holds 3. The way I like to think about it is, let's say you had two buckets, right? Bucket A and bucket B. A holds some sand and B holds some water. How would you get the contents of these two buckets to switch around? That's basically your goal for this challenge. But there's a couple of rules that you have to follow in order to get the correct answer. Now, first, you should not change any of the existing code. So don't touch this part and don't touch this part. You are just allowed to write in these 3 lines. Now, the second rule is you're not allowed to type any numbers. You can't just simply say, well, A equals 8 and B equals 3. This is not a valid solution. Now, the final rule is you're not allowed to redeclare the variables either. So you can't, for example, just say, well, now A equals 8 and B equals 3. This is also wrong. So have a think about how you can solve this challenge given all of these constraints. And over here, I've got a code playground set up for you. So when you click on it, you should be taken to the same file where you can write your code. And you can use this playground to test out your code. So for example, at the moment, if I just click run, then it's going to log that A is 3 and B is 8. Now what we want to happen is when we hit run, it should say the opposite. A is 8 and B is 3. So have a play around with the code and use the replit to test out your code and your hypotheses and hit run to see if it actually does what you expect it to. And then once you think you've got the solution, then go ahead and write them in your code file here, and you can click on checked solution to see if you got the answer right. Now, once you're done, you can click continue and I'll talk you through the solution code. So head over to the next lesson and start the code challenge. Alright, so hopefully you gave that challenge a good go and you managed to get the correct solution, abiding by all of the rules. Now, the rules are there because we want to test your understanding of variables. And this particular exercise is something that you often see in coding interviews where they're trying to test a candidate's thinking process, how they go about reasoning using code. So let's go through the solution together and see if you got it right. Now, as I mentioned previously, we're not allowed to change any of the existing code, so the solution can't just be us changing this from 3 to 8 and that from 8 to 3. This is wrong. The second rule is we're not allowed to type any numbers, so we can't just simply say, well, A now equals 8 and B now equals 3. This is also wrong because it breaks the second rule. Now, the last rule is we're not allowed to redeclare the variables a and b. So finally, we can't say a equals 8 and variable b equals 3. In this case, we've actually just created two new variables, and you can see we're getting a little warning on the side. And it says that a is already defined, b is already defined up here. So we can't redeclare them. So given all of those constraints, how do we arrive at the answer? Well, as I showed you earlier on, it's really useful to think about it in terms of real objects, to understand the logic. Now, we said that we've got two variables, right? A and B, and we can imagine them as two buckets, bucket A and bucket B. Now, A contains sand and B contains water. How would we switch the contents of the buckets around so that A holds water and B holds sand? Well, if this was a real life situation, then the simplest way is probably just getting hold of another bucket, right? And this is exactly the same solution that we're going to implement using code as well. So always remember that coding is not the hard part. Remembering what the semicolons are, the equal sign, this is all very easy. The difficult part is getting the logic in the first place. So let's create this variable c, and let's get it to hold some of the content that's currently inside A. And now that A is freed up, we can use A to hold what's inside B, and finally we can get B to hold what is inside C, which is what was previously inside A. So now let's go ahead and test our code. So I'm just going to copy these 3 lines and I'm going to paste it inside here. And when I hit run, you can see that now A is 8 and B is 3. And just these 3 lines of code allowed us to do the bucket switch. And if we click check solution, then everything should pass and we should be allowed to continue. So how did you get on with this challenge? If you got really stuck and you don't understand why the solution is the way it is, then I urge you to just think about the buckets. Think about how you would do it in real life. What is the logic of switching the contents between A and B around when you have a bucket C? And then the code is going to become a lot more easily understood. So if you need a moment, pause the video and have a think about it. And then once you're ready, head over to the next lesson.